For Chapter 10, we are going to discuss chemical reactions and chemical equations. I look at chemistry as having its own language. We have now talked about the elements and their symbols, and that is, to me, the alphabet of chemistry. And then we moved on to writing compounds from these elements, and those are the words that we use in chemistry. And then finally, we are now discussing chemical reactions, and that would be more like sentences of a language, where we put chemicals together and we display them in the way the reaction happens. So here are the sections that we are going to cover, and we will start with how to recognize that a chemical reaction has occurred. Chemical reactions occur when we have rearrangement of the atoms from the original compounds that we have. However, going back to the law of conservation of mass, we cannot create or destroy atoms. This tells us two things: that the elements, so the symbols of those atoms that appear on the left-hand side of the chemical reaction or equation, should also appear on the right-hand side, which is after the reaction has occurred. We should have the same elements, albeit rearranged, but if I have oxygen on my left-hand side, I should have oxygen on the right-hand side as well, because I cannot destroy an atom completely in a chemical reaction. We just rearrange them. The second thing that this tells us is that the number of those atoms, so the element of oxygen, for example, that I just mentioned, should be equal on both sides, because that means that we can't have more because we've created, or we can't have less because we've destroyed. We need to have the same number of atoms on both sides, atoms of the same elements. And you can see here we have two different reactions that are occurring here, chemical reactions. We all have seen rust. What happens to iron? It rusts. It forms a completely different compound that has different chemical and physical properties, and that looks differently than when we started. Same thing when we bake a cake. When we put the batter into the pan and we put it in the oven, we have started the chemical reaction, but it takes, temperature will help it, right? It will help it, but the chemical reaction occurs, and my second state, so what I end up with, is not what I started with at the beginning. Let's take a look at a sample problem. In diagram A, I have the initial compound, which is made up of atoms of two elements, which are represented by a red and a green sphere. So my molecule that I have initially is a diatomic molecule that has a red and a green sphere. If we look at the diagrams B, C, and D, which of those represent a physical change and which represent a chemical reaction? Remember that in a chemical reaction, I have complete rearrangement of my original molecules. If it's just a physical change, my molecule will not change. It will look the same. It may just change, we mentioned those already, from a solid to a liquid to a gas, but it is not a completely different molecule. Okay, take a little bit of time to decide which B, C, or D, so which of these diagrams represents a chemical reaction and which represents a physical change. Check all that apply. Okay. In a chemical equation, we use chemical symbols to write the process of the chemical reaction. So what is happening in the chemical reaction? The chemical equation represents a chemical statement. I just mentioned that we use these chemical equations as words in a sentence. So if I have this reaction over here, I would read this as ammonia, which is this compound, and hydrogen chloride, which is this compound, react together to produce. This arrow tells me that it produces ammonium chloride, which is this compound here. So I move from left to right. Whenever I see an arrow, that tells me that I've transitioned from my initial compounds, which are called reactants, to my final products, final compounds, which are called products. Now we can have one reactant and several products. We can have several reactants in one product, like we have here, for example, or we can have multiple on both sides. It doesn't matter. We can read this as a sentence. So ammonia and hydrogen chloride react together to produce ammonium chloride. Each species that appears to the left of that arrow is called a reactant. I just mentioned that. These reactants are molecules that are consumed when the chemical reaction happens. Or the consume idea, it kind of goes against the destruction or creation of molecules. What we need to say is these are those substances that rearrange, in which atoms rearrange to give you different compounds, right? So these are your starting substances, and you end up with something different to the right hand of that arrow. So those pieces that appear to the right of the arrow are called products, and they are formed during the course of the chemical reactions. So we use up the reactants and we form products. However, the important thing to remember is that even though we're using up the reactants and forming products, we cannot create or destroy atoms. That means that elements on both sides have to be the same, so the same type of elements, and they also have to have the same number of atoms on both sides. Several nonmetals, and we've kind of mentioned it earlier, but they exist as polyatomic molecules, more specifically diatomic molecules, and we will use them this way when we write equations with these. For example, here's some diatomic molecules and one that is polyatomic. We can also add S8 here, but we probably won't go that far to use pure sulfur. But hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine all appear as diatomic molecules. When you read the words hydrogen gas, for example, reacts with oxygen gas to produce water, when we write that in terms of from words and we translate it as chemical symbols, anytime you read hydrogen or nitrogen or oxygen, etc., the names of these, when we write them, they will appear as H2 or N2 or O2, not H plus O gives you water. It will be H2 plus O2 gives you H2O. And then P4, which is a polyatomic molecule. So anytime you see phosphorus reacting with oxygen, for example, you would write P4 plus O2, giving you product. I would once again make note of these molecules so that you have them handy and know how to write their formulas from their names to be able to write the correct chemical reactions when you have to start from actual names of the molecules.